Mr. True. In this video, we're going to do 3 examples involving finding derivatives using the chain rule. We're not going to be focusing on any kind of trigonometric functions in this video. That will be for the next one. And down below, you'll find a timestamps to jump to any one of the 3 examples you like, as well as a link to the homepage of my channel and website where you can find any one of my 740 plus math videos I've done to this date, from Algebra 1 to Calc 2 and Statistics. So let's get started. The chain rule. So far, at least unless we're talking about trigonometry, we have a few rules for finding the derivative of a function. We have the derivative with respect to x of a variable base and a fixed exponent, which is going to be bring that power down and have x times n to the n minus 1 power. We have a rule for the product of 2 functions. If we're taking the derivative with respect to x of f of x times g of x, that's going to be the first times the derivative of the second plus the second times the derivative of the first. Or just to put that into full language, we have the derivative of f of x times g of x is equal to f of x times g prime of x plus f prime of x times g of x. And we have the derivative of a quotient, the derivative of 2 functions being divided together. So we have the derivative with respect to x of f of x divided by g of x. And we have a little sing-song for that, right? Because unlike the multiplication rule that has addition, addition and multiplication, both functions of which are commutative, the answer for the derivative of a quotient has subtraction in the numerator. So you got to make sure you get the order of that subtraction correct. So we have low, so g of x, d high, derivative of the numerator, so g of x times f prime of x, minus high, f of x, d low, f of x times g prime of x, all over low, or g squared of x. Low d, and the d stands for derivative, obviously. So low d high minus high d low, all over low. Okay, now for these 3 derivative rules that we have that don't involve trigonometry, and this is actually a true statement for even those, you may have noticed, and if not, let's point it out, the variable with which you're taking a derivative with respect to, so a derivative with respect to x, and that variable base was x. Derivative with respect to x and the independent variable of x and g were just that. So far, for all of our problems, the sort of independent variable, if you will, has been the same as the variable with which we're taking a derivative with respect to. That is not always the case. So we're going to learn something called the chain rule, which is, what do you do if, well, let's take the power rule. What do you do if the variable base is not just simply x? It's not an exact match to the variable with which we're taking the derivative with respect to. And once you learn the chain rule, it's going to apply to all of your derivative rules, whether it's product or quotient or all 6 of the trig functions that we have learned the derivative rules to, such as the derivative of the sine of x is cosine of x. Maybe probably should have kept those up there to finish this one. At any rate, no, what we're going to do now is, instead of the product and quotient rule, the chain rule is about the derivative. Let's just get all this out of the way. The derivative, it's still going to be with respect to x, but instead of a multiplication or a division of 2 functions, it is going to be a composition of 2 functions. So we're going to be taking the derivative with respect to x of f of, and I'm not going to put an x in here, I'm going to put f of g of x. And what do you need to do to effectively find a derivative using the chain rule? Well, what you're going to need to do is identify what is the function that is inside of another function. What is that composition? This is something that I cover with my pre-calculus classes, and I'm sure you as well, where we had maybe a complex function and we pulled it apart and we could kind of identify what's the small function, if you will, going into the big framework. So the chain rule is about the derivative for the composition of, in this case, the sort of standard formula is the composition of two functions. G of x is getting put into f of x. But it can be, you know, there might be like a function within G, which is then within F, and so you can do multiple stages or multiple steps of chain rule. You're going to see that through the three examples. And how do you take the derivative of a composition of functions? Well, you know, when I give you an expression, like say in Algebra 1, when you were given an expression and asked to simplify, you worked with the innermost parentheses first, simplified everything in there, and then worked your way out to the next set of parentheses, and maybe you worked out again to the next sort of larger grouping symbol, and you worked your way out of the parentheses. Well, with derivatives in the chain rule and a derivative of a composition of functions, you do just the opposite. You start on the outside and work your way in. So the derivative of, with respect to x, of f of g of x is equal to f prime. So we're going to be taking the derivative of the outside function, f prime of, now pay attention because this is a really common mistake, g of x. Do you see there? There is no prime symbol on this g. We're leaving that inside function, which I'm going to try and keep highlighting. Remember to highlight it in orange, which I'm going to hope is going to show up on the camera. We're going to take just the derivative of the outside function. When we're finished with that, and we're going to keep the inside function as is, we're then going to multiply by g prime of x. So in the first sort of factor of our answer, we're only taking a derivative of the outside function. And then the next factor in our final answer is going to be the derivative of the function that's inside the original function. And if there's sort of like a composition of three functions, you'll then just keep adding on, working from the outside and in until you're finally complete. And when you know you're done, when the sort of, pointing to just this x, when there's nothing else inside of another function other than just simply x, or you're kind of looking at that independent variable, which is matching the variable with which you're taking that derivative with respect to. Now, I like it more to say what I'm about to say when we're dealing with integration as opposed to derivatives, but you may start seeing some rules show up in terms of this sort of like U substitution, if you will. So in other words, what I'm going to say is here we have that power rule as an example. That power rule was the derivative with respect to x of a variable base fixed exponent. Exponent comes down, keep the base the same, n minus 1. Well, the general power rule in textbooks will kind of like bring up this idea of a general power rule, and they don't really state it, but really every derivative rule from here on out, even the 6 trig functions that we've learned so far and the product and quotient rule derivative rules, you can think of it in terms, once you learn chain rule, you're going to see them, you're going to want to write and memorize them as general rules. Now what does that mean? That means that we have the derivative with respect to x, and my x is going to be replaced with a u to the n. Okay, so notice that the independent variable here, and it isn't going to usually, until we get to like related rates or implicit differentiation, this base isn't going to be just a variable that doesn't match the variable with which we're taking a derivative with respect to, but it's more than likely going to be a whole like expression. So what we do is we're going to, again, looking up here at this formula, we're going to look at that outside function, which is in this case that power of n. That power of n is still going to come down. We're going to then have that base of u. We're going to reduce the power by 1. So far the general power rule is looking the same, similar or the same as the non-general power rule, but we're taking a derivative with respect to x, and this base is not x. So this is going to be followed up by the derivative of u with respect to x, only you won't see that in a book. What you're going to see instead is a u prime. And you're going to see like a derivative of something with a u instead of x, and then all of those formulas are going to be finished up with a u prime. What really is happening there, I don't really like this notation with derivatives. I save more sort of like u substitution talk for integration. But what you're really doing is the derivative of y with respect to x is equal to the derivative of y with respect to u, okay? That expression or variable that doesn't match this variable with which we're taking the derivative with respect to, times du over dx. The u prime is that sort of shorthand notation of writing du over dx. And while this calculus notation isn't literally division, we can see that kind of like when you're canceling units out in chemistry, if you will, the du over du cancels, and we have dy over dx is equal to dy over du, the derivative of that outside function with respect to u, times the derivative of u with respect to x. I like the composition, stressing the composition idea more, and starting from the outside and working your way in as you learn the chain rule. Finally, with all of that introduction, we're going to start our 3 examples right now. So for example number 1, we have got an iPad that is turned off. We have got f of x is equal to 3 times the cube root of 2x squared minus x. And I never work with radical notation, so the first thing I'm going to do is not take a derivative, but rewrite this as with a rational exponent. So we have f of x is 3 times 2x squared minus x raised to the, well, everything in here, I don't see any additional exponents, has a power of 1, so all of that inside the groupings, the math symbol, cube root, is 1 over that root of 3. Okay, so do we see a composition of functions? There is a 3 times something, and I use that phrasing when we talk about function notation and maybe and introducing compositions in Algebra 2 and pre-calculus, that maybe the outside function isn't a 3x to the 1/3, but it's 3 times something, an open place to put an expression in, 3 times something raised to that 1/3 power. Inside the power of 1/3, we don't have just an x to the 1/3. We got a lot going on. We have a u or a g of x, an inside function, I'm going to use green instead of orange, of 2x squared minus x. So keep an eye on that. That's the inside function. That is our g of x. I probably should have stayed with orange since that's an orange. Okay, so we're going to find f prime of x. I just took a derivative of the left-hand side and there's nothing going on there, so I just wrote f prime, is equal to, now this 3 is in front of the main math function of something to the 1/3 power. So that's a constant multiple. So we're going to leave that out front. And I'm going to show this just for teaching purposes. The derivative with respect to x of 2x squared minus x raised to the 1/3 power. Okay, so step 1, the derivative of a composition of functions is to take a derivative of the outside function first. Take a derivative of that variable base raised to an exponent. So we're going to bring that power of 1/3 down. So we have 3 times 1/3, bringing that 1/3 down. We're going to leave the inside, see this just says g of x, not g prime. Keep that inside the same, which I should keep in orange, or not orange but green. So I'm not touching that inside. And 1/3 minus 1 is negative 2/3. Now that's just the derivative. This is just this piece here. We just took the derivative of the outside function, used the power rule. Now we're going to finish by doing times g prime of x, times the derivative of the inside function with respect to x. I'm not going to do it, I'm just going to write it. So we're going to do times the derivative with respect to x of 2x squared minus x. And hopefully you're seeing here a problem similar to what we've been doing in class, or you've been doing in your class at home, where you're taking the derivative of just 2, which is a constant multiple. We have a base of x. The base of x inside the power of 2 is an exact match to d of x. And then we have a minus x. So the rest of this is going to be like just using that basic power rule, if you will, that we've been doing for the number of days now. We've only got one step left, so we're going to just say that we have f prime of x is equal to, well, 3 divided by 3 is equal to 1, so this is going to go away. And we have 2x squared minus x to the negative 2/3 power. I guess we got one more step. The derivative of 2x squared, that power of 2 is going to come down, so we have 2 times 2 is 4, times x to the 1 power, or 4x. And then minus the derivative of x with respect to x is equal to 1. And we have an answer that basically is made up of sort of two factors. This base has a negative exponent, so our final answer is going to be f prime of x is equal to 4x minus 1. I'm going to write a big old fraction bar, so really that parenthesis is not needed. All over, I'm going to write this as a radical notation. We have a root of 3, so the cube root of 2x squared minus x, and then this power of 2 there, and this is the end of the first example. Bam! Example number 2 coming up right now. Example number 2. And the first thing you need to do when you go to take a derivative is see, again, look at that expression, look at that function, and see what derivative rule it most closely matches. Is there a trig involved? Is it sine, cosine, secant, cosecant, tangent, or cosecant? Is it a composition? Is it a product? All that good stuff to kind of give you some direction of where to go. So let's stick with the orange like I should have done the last one. And remember, every math operation is really basically also a grouping symbol. Anything inside of a square root needs to be all, simplified and square rooted before you apply anything else that's on the outside of that root. So our most outside parentheses are these right here, which we can see above in the upper right-hand corner. We have an exponent of 3. So there's a lot of stuff being raised to the 3rd power. So everything that's inside this parentheses that is a base of 3 is a composition. All of this 1 plus t squared plus 3 raised to the 4th, all of that is g. Okay, now looking inside the base of 3 in this expression, do we see, like an expression inside of another math function? We have another power of 4, and inside that power of 4, or as a base of that 4, we don't have just a t of raised to the 4th power. We have a whole expression being raised to a 4th power. So we have a composition within a composition. So hopefully we can see this blue that I'm about to use. And we have t squared plus 3. That is all inside the 4. So we're going to have more than just sort of one step of taking a derivative of this using the chain rule. We're going to have to use the chain rule twice. One for the orange inside function inside that power of 3, and one more for the blue expression now that's inside the power of 4. We're going to just do it one step at a time. We're just seeing this probably for the first time. Maybe you're reviewing for a test. But we have f prime of t. And we are taking everything now derivative with respect to t. So we have over here all of this base being raised to the 3rd power. So the 3rd power comes down. We're going to have 3. And then I'm just going to copy everything else out. We have 3 times 1 plus parentheses t squared plus 3. Close the parentheses. That's to the 4th power. Close the parentheses, and we're bringing this power of 3 down to a 2. What I've written right there is the f prime of g of x. I've kept everything on the inside of that, what was a power of 3, now a power of 2. I've kept that inside the same. Now we're going to write the times g prime of x, but just show what I'm about to do. So we're going to do times the derivative with respect to t, and I'm just going to copy the entire inside expression that was inside the power of 3 that's now inside the power of 2. So 1 plus, parentheses, we're going to keep the stuff inside the base of 4, blue, t squared plus 3, raised to the 4th power. All right, so we're going to take the derivative of 1, and we're going to take the derivative of something being raised to the 4th power. And keep writing all this other stuff down as we go. So 3 times 1 plus, parentheses, t squared plus 3. Close the parentheses to the 4th. Close those parentheses to the 2nd. And parentheses, the derivative of 1 is 0. Plus, now we're taking the derivative of something to the 4th. So that 4th comes down. So we have 4 times. We're going to keep the t squared plus 3 intact because we're working just one function at a time, working our way from out inward, kind of like we're peeling an onion. So the power of 4 comes down, we reduce that power by 1. We have to, like as I have highlighted in blue, we had 2 compositions, so we got to do 2 steps of the chain rule. So we're going to be doing the derivative with respect to t of what was inside the power of 4, now inside the power of 3, the derivative with respect to t of t squared plus 3. Now I know there's only one more step left because 3 is a constant, and inside the power of 2 I just have a base of t, a base which is an exact match to the variable with which we're taking the derivative with respect to. So let's go. We've got, well, we can do a couple of things here. The 4 is going to come over and connect with the 3, so we have 4 times 3, which is 12 times 1 plus t squared plus 3 raised to the 4th power squared. We should leave some more space between these 2 lines. Times t squared plus 3 to the 3rd power. And now I'm going to open up a set of parentheses as we go through this next step. The derivative with respect to t of t squared, the 2 comes down. The exponent gets reduced by 1, so we have 2t, and then the derivative of 3 is a constant, that's going to be 0. So we just have 2t. So our final answer is f prime of t is, let's see here what, we got 12 times 2 is 24, so I was about to write something wrong there, so we have 12 times 2 is 24t, so we have 24t, parentheses, 1 plus, parentheses, t squared plus 3 to the 4th, raised to the 2nd, all of that raised to the 2nd, times t squared plus 3 squared, and I brought the 2t out front, and we are done. And that, hopefully, is exactly what I got when I pre-made these notes. Good. Okay, now before we go on to the next question, I feel like I need to do this. The derivative with respect to x of, say, x squared is what? I know we've already done this before, but I'm going to bring the power down. I'm going to identify that we have that base of x, and I'm going to reduce the power by 1, so we have 2 times x to the 1st power. Now, if I think, at this point, now that we've learned the chain rule and how it's a composition of functions, you could literally, if you want, do every single problem as if it were chain rule. So the 2 comes down, we're reduced by 1, we have 2 times x to the 1st, and now multiply by that sort of g prime of x, multiply by the derivative of the inside function with respect to x. So we're doing the derivative with respect to x of x. Well, that's really kind of like an x over 1, and it appears to be, and indeed it is, canceling out. Dx divided by dx is 1. See, so you could really argue that we've been doing chain rule all the time, we just didn't really know it. We're going to do example 3 coming up right now. Example 3, and it's our last example. We have g of x is equal to 1 plus x over x plus 3, all raised to the 3rd power. And yes, here we're going to only have one step of chain rule where we have the lot going on inside the power of 3. We've got the quotient 1 plus x over x plus 3. That's our g of x. That's our inside function. That's our u that is inside the power of 3. But we got kind of a lot going on here, so we're going to start with a general power rule, or power rule involving chain rule. And then for the inside, we're going to shift gears into another type of differentiation, the derivative of a quotient. So once you start learning multiple rules, they're going to interplay and interact with each other all the time. So we have g prime of x is equal to, we're taking a derivative with respect to x, the power of 3 comes down. We reduce that 3 by 1, so now we have 3 times something to the second instead of something raised to the third power. That something on the inside is, I'm going to turn this 1 plus x around to be x plus 1 since addition is commutative. So we have x plus 1 over x plus 3. That was the composition, that's the u, that's the g of x, that's the inside function. So now we've taken a derivative of the outside function, the power. Now we're going to multiply by the derivative of the inside function, which is the division of two functions. And since our denominator is a binomial, there's no way around this. We have to use the quotient rule. So now we have g prime of x is equal to 3 times x plus 1 over x plus 3 squared. And I'm not going to worry about actually expanding the numerator and denominator, because a lot of times when you're taking derivatives, you'll start to see common factors show up, and maybe you can save yourself a little work. Now, the derivative of a quotient, we just had it up there on the board a minute ago, it's low. So x plus 3, low d high. D high, the derivative with respect to x of x is 1. The derivative with respect to 1 is 0, so we're just looking at x plus 3 times 1. So low d high minus high x plus 1 d low, and the derivative of x plus 3 with respect to x is just going to be 1 all over low low. Again, we're going to visit some chain rule involving trigonometric functions in our next video. Now look at here, see, we have x plus 3 squared in the denominator of our sort of second factor, if you will. And we have an x plus 3 squared in the denominator of our big ol' third factor. So we're going to write this denominator as x plus 3 to the fourth power. We have a factor of 3 in the numerator. We have x plus 1 squared. And now what do we got going on over here? We've got x plus 3, that's times 1, so whatever. X plus 3 minus x plus 1. We can distribute that negative 1, but I don't think it's enough to just write a whole new line. So we have x minus x is 0, and we have 3 minus 1 is 2. And I guess that means we could do 3 times 2, so our final answer is going to be that g prime of x is equal to 6 times x plus 1 squared all over x plus 3 raised to the fourth. And that's it. I'm Mr. True. Bam! Go do your homework.